Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, I explained how to create a colorful square using a single GPU buffer. In that example, we always duplicate some vertices whenever two triangles share the edge. You can see here, these two triangles ABD and DBC share this line D and B. So vertex D and vertex B appears twice. You can see B here and B here, D and D. So this B and D appears twice in this vertex data array. This is a very simple square. For a complex 3D graphics object, there will be more vertices that duplicate multiple times. This is very inefficient in create WebGPU graphics applications. In this video, I will introduce the index buffer, which enables us to reuse the same vertex over and over again. In this case, the vertex array only contains a real number of vertices. For our square, we need only 4 vertices. You can see here. This vertex data will only contain the ABCD. This is real number, just the 4 vertices. We can define the index as the vertex appears order in this array. For example, the first vertex is index 0. The second one is index 1, and so on. So this order represents the index. We can also define the index array, like here. You can see in our case we contains 6 integers here. Every 3 integer represents a triangle. Here you can see 0, 1, 3 represents the ABD, this triangle. Another triangle is 3, 1, 2 represents this triangle, DBC. So we can use this vertex data plus this index data represents these 2 triangles. These 2 data is identical to this vertex data. But here we don't need to repeat these BD vertices. We just use the index here represents the triangle. Again, we will use the Git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download the source code used in the last video. Now open a command prompt window and run the following command: git clone. Okay, this will generate a WebGPU 08 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of the WebGPU 08 to the GPU 09. Rename and cd into this new folder. At this point, we are going to start Visual Studio Code with the command code period. Okay, this is Visual Studio Code interface. We can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window from here and use the npm install command to recover the npm package. This installation will take a while. Please be patient. Okay, finished. Now all the installed packages are stored in the node modules folder. Now let us make some changes to the index.html file. From this dist folder, open the index.html file. First, we need to change 8 to 9 because this is the 9th video series. We also need to change the H1 title, create a square, use index buffer. we still keep the canvas elements and assign ID as canvas WebGPU. We also fix its size. Now we can save this file. We can reuse the same shader code used in the last video, so we don't need to rewrite any shader code in this example. Regarding to the TypeScript code, we can also reuse most code implemented in the last video. In particular, we will use the init GPU and create GPU buffer methods we created previously in the helper.ts file. Here, in order to create the index buffer, we also need to add a new method to the helper.ts file. So from this src folder, open the helper.ts file. Now, we need to add a new method here. You can see the name is create GPU buffer uint. Uint means input the data is uint 32 array. Uint is unsigned integer means. Compared to the original create GPU buffer method, you can see the data here is float 32 array. Because for the index is integer, so we have to change the data type to uint 32 array. Another change is the default usage flag. Here we change it to index. Here is vertex. Here is index. That's all we need to change. Now we can save this file and close it. Now we need to make some changes to the main.ts file. From this src folder, open the main.ts file. Here we first introduce this new method, and also we need to introduce the newly created method create GPU buffer uint. This is for create the index buffer. Inside the create square method, we first call init GPU method to create the GPU object. From this GPU object, we create the device. This device will be used to create a random path and a random pipeline. Now, this vertex data needs to be replaced using the following code. This data just contains 4 vertex data. We also define the index data. So you see 6 integers represent 2 triangles. This we already discussed previously. Next, we define the vertex buffer using the vertex data. We also need to create the index buffer using the index data. So here we can copy this code and paste it here. And we can make the change index buffer. And here use a new method uint. And here we change it to index data. So here we use vertex data and index data to create 2 buffers. One is vertex buffer and another is index buffer. Now we have a buffer attribute inside the render pipeline. But here we don't need to make any change to this attribute, because here array stride we still have 5 floating 32 numbers for each vertex. So here array stride still 20. So we still assign shader location to 0 for the vertex position and shader location to 1 for the vertex color. Similarly, the offset is 0 for the position and offset is 8 for the color. This code is the same as that used in the last example. So we don't need to make any change to this code. One thing we need to do is random pipeline set vertex buffer here, right? Right now we need to add the index buffer to this render path. So here we need a render path set index buffer. This is index buffer and type is uint 32. So that's a little bit different from here input parameter. For the vertex buffer, the first one is slot assignment. Here we use 0 slot for the vertex data. But here, we don't need to specify the slot. We directly use the index buffer and specify the data type. Here we use uint32. Finally, we need to change the draw method because right now our vertex is indexed, so we need to use the draw indexed. So inside this, the number of vertices still is 6 because we still use 2 triangles specified by 6 integers in the index buffer. Now we finished the modification to the min.ts file. Now we can save this file. As mentioned before, we don't need to make any changes to the shader code. We can use the same shader code as in the last example. This means the shader code does not care about the configuration of the GPU buffer, whether you use the index buffer or not. This sense will be taken care of by the TypeScript control code, but not the shader code. The only thing matters is the data assignment to the shader location. From this shader location mapping, the shader can access relevant data. In other words, the shader code does not care about the configuration of the GPU buffer, nor does it care about the data allocation scheme. It only cares about the actual data assignment to the shader location. So that gives you more flexibility to configure the input data. Up to now, we have finished all the programming for this example. Now we can run the following command on the terminal window to bundle our TypeScript code in production mode. npm run prod. Okay, the bundle file is created successfully. You can see the main bund.js file is about 4.23 KB, so it is still very small. Now we can find the link from this status bar, the Go Live link. You can click this link to open the Chrome Canary to view our colorful square. So click this link. Here is our square with different vertex color. Here is red, green, blue, and yellow. From one vertex to another, you can see the color changes smoothly because WebGPU interprets the color internally, which gives a smooth color gradient. In the last 2 video series and this video, I explained how to create a colorful square, use different GPU buffers. My intention for doing this is to demonstrate that you can use different approach to create your WebGPU applications. Now we have finished this example. I have created a GitHub repository to host the source code used in this video. I will post the link for the source code below this video. You can click the link to download the source code. I will end this video here. In next video, I will show you how to create a 3D cube with distinct face colors. See you next time. Bye.